Welcome to Ask and Learn.
Two pi. The intercepts are y. Let's set either x or y to 0, and we see that we have an intercept at 0, 0. We have no symmetry and asymptotes. Let's test. We do have one as x approaches infinity. So as x approaches infinity, what is our asymptote at y going to be? Now this is a horizontal asymptote, so testing as limit of x approaches infinity of our function e to the negative x sine x. All right, and that equals 0. So we have a horizontal asymptote at y equals 0. Okay, and now we can do the first derivative test to look for increasing and decreasing intervals. So y prime equals negative e to the negative x sine x plus e to the negative x cosine x. That's just power rule. And set that equal to 0. We have a critical point at x equals pi over 4. So if we do the first derivative test, testing values in our first derivative around pi over 4, we can see that it's increasing smaller than pi over 4 and decreasing if it's greater than. So if it's going from increasing to decreasing, we know that this is a local maximum value. So, and if we do plug into our original function, if we plug in pi over 4 into our original function to see the y value, we're going to get approximately 0.32. So this is our local max. And now we can solve our second derivative to look at concavity. So y double prime is equal to negative 2e to the negative x cosine x. Set that equal to 0. Take our f double prime. This is our second, oh, we didn't solve this yet. X equals pi over 2. So if we look at pi over 2 in our second derivative test, we see that it's concave down for values below pi over 2, and if it's greater than pi over 2, concave up. So concave down and then concave up. So that means that this is an inflection point at pi over 2. Okay, and now we can graph. The first thing I would do is graph the asymptote. And since we're only looking at our domain from 0 to 2 pi, I'm just going to draw the positive first quadrant. Okay, so our asymptote is at y equals 0. So it's the x-axis. This is a horizontal asymptote. And we have an intercept at 0, 0. So that's right here. And let's say this is pi. And that's 2 pi. So we have a local maximum value at, and let's say this is 1. So we have a local maximum at pi over 4 and approximately 0.32. So that's going to be about, this is pi over 2, this is about pi over 4, 0.32. So let's say it's about there. It's just a rough sketch. And we have an inflection point at pi over 2. So that's about here. So somewhere here. And now we can see that it's going to be increasing and then decreasing after it hits our local maximum value, and it's going to be concave down and it's going to now decrease and continue being concave down until it hits our inflection point. Now it's going to be concave up and approach our asymptote, but never touch, as the values get closer and closer to zero.